Hi, everyone. Welcome to your Capstone Defense. We're going to go ahead and get started with introductions. My name's Bree, and I work on operations. And I will pass off to Aaron.
Yep, my name is Aaron, and I'm the program director of the data science program. Excited because this is our first Capstone Defense.
Yay. Sean.
Hey guys, I'm Sean, CS. I'm a CS instructor here.
Brian.
I'm Brian. I'm the Lambda Labs director.
Dustin.
My name's Dustin. I'm a web instructor here at Lambda.
Alex.
My name's Alex, and I'm a data scientist.
Navjot.
Hello, I am Navjot, and I'm a machine learning engineer.
Darwin.
Hi, I'm Darwin, and I'm a data engineer.
And Antonio.
Hi, I'm Antonio, and I'm a data scientist.
Perfect. If I could have somebody from your team go ahead and share their screen and start your project demo.
Sure, let me know if you guys can see the screen.
You're good.
Cool. So our project is Resume AI. Resume AI is an AI-powered resume assistant for end consumers, aimed at increasing their chances in the selection/screening process, which happens when you send out your resumes. And the idea is basically that given a resume and a job posting, how can AI help us to find parts of the resume which can be tailored or improved or tweaked to increase the chances of getting selected. That's kind of the rough idea. I can do a quick demo. The product is very simple. It starts with the two very simple buttons. You choose a resume. So I click here, I choose one resume, and you choose a job posting, and you hit analyze. Behind the scenes, what we do is we break down the resume and the job description and try to get some meaningful information for the user. So first section we display is the missing part. So these are the stuff which were missing in the resume but were a requirement in the job posting. So you can see that the job posting had a requirement of bachelor's and maybe some years of experience. And we have purposefully taken an extreme example here. And this is the resume of a Lambda school CS student. So you can see that this stuff is missing because the person might have just gone through 6 months of a computer science course. Next, what we do is we break the resume down into roughly sentences and try to give a score to it, so that the user can kind of drill down what things are not favorable as per the job description which he is currently interested in. So quick examples here. Let me pick the education one. So this person lists under his education that he completed 6 month full-time computer science development program. And you can see that it generates a score of 11.3. Furthermore, we can see that some stuff like front-end stuff like jQuery and Bootstrap generated a score of 44%, but more all-around technologies like C, C++, and a lot of other stuff kind of generated a higher score. That's kind of the rough, high-level idea behind the product. And further down, what we do is we display a view where the user can see how the keywords he or she has used in his or her resume is standing against the job description. So in this view or in this plot or graph, what we have done is we have plotted 4 different colors. The gray is all the words we have gathered from the data we have. The green is the common ones which both the resume and the job posting have, and the red is the missing one, and yellow is the one which the resume has but the job description doesn't have. So like quick couple of points how this can be useful. You can see there's some green stuff. So find the resume had C++, and so did the job posting. So that's a good point. A quick example of where it helps, where what you might have missed something is it shows that HTML and HTML5, which is showing in kind of red color. That means that the job description required or job posting required HTML and HTML5 as skills, but the resume did not mention it. And just judging by the fact that the person worked with jQuery and Bootstrap, which are front-end technologies, it's pretty obvious that he or she must have touched HTML and HTML5. So by this kind of view, you can quickly judge what kind of keywords are missing and can have some idea about how to improve your resume and tailor it to the job posting. That is it. Like, if we can go into more details, but this is like the high level demo. Any questions?
Instructors, do you have any specific questions while he still has the project up?
I do have one question. Could you explain a little bit about the spatial mapping of the data in that plot?
Yeah. So the axis or let's start with the gray points. The gray points are what are called word embeddings, and how they are generated is basically we take all the data, whatever resumes, job postings we have, and we run it through a machine learning algorithm, which what it ends up doing is it ends up clustering similar words together. Not similar in the sense that similar sounding or similar meaning only, but words which occur together. For example, let's take this little cluster, which is more meaningful for the web perspective. So you can see Node, Express, MongoDB, Mocha, and all the stuff is kind of occurring together. And this is a complete unsupervised technique. We have not informed the model or the machine learning model that, well, Node is kind of related to Redux or Mongo or anything. It just saw that these words kind of always occur in clusters or in nearby neighborhoods. So it ended up clustering together. And this is the same way these other circles are useful, or red or green, because what you can see is, let's say hypothetically you did not use HTML, hypothetically, but you did use CSS, for example. That's not a good example, but for the sake of understanding. So you can then see, well, I didn't use these two red boxes, but let me see what other stuff is there around it, because these are kind of similar, and I can put maybe CSS and CSS3 in my resume. And what that'll end up doing is that it still increases your chances of screening process, because on the other end, when you send your resume, a similar AI layer tries to screen the resume and tries to reject or pass the resume. And if HTML is going to score 100% score, then CSS is going to score very close to 100% because they're very tightly kind of clustered together. So that's kind of the idea behind this plot.
Okay, that's very cool. So am I understanding right then that the numbers on the axes don't really have a meaning?
No, they don't have a meaning. These are just the two most, you can say, two best dimensions where we could express these embeddings in a 2D space. Ideally, these are like a high dimensional space, like 100 dimensional space or 300 dimensional space, but we have kind of compressed them to two dimensions.
Yeah, that's exactly the question I was going to actually cut in with. You already mostly answered it, but just to be clear, so do you know roughly how many dimensions the word embeddings were originally, and this reduction is just the two most important, or what technique did you do to generate this reduction down to 2 dimensions?
Sure. So the original embeddings were 100 dimensions. That's what we went with. And we used a technique called TSNE, which is a dimensionality reduction technique to bring it down to 2 dimensions. Does that answer your question, Aaron?
Could you, I guess my follow-up question to that would be, could you give sort of a rundown of CSME? As I don't know what that is, and you kind of just threw it out as like a That's what I'm looking for. Basically like a buzzword, right? Can you kind of summarize a little bit of how that works?
Okay. Yes, I went a little bit fast because I wasn't sure what parts I should focus on. So let's start with from the start. So we uploaded a resume and a job description file. Behind the scenes, what we are doing is we go one by one. First, we take the resume, we break it down to what you can say roughly sentences, and the idea behind doing that is that we don't want to generate one single score for the whole resume, which many hiring agencies anyways do. Their purpose is to reject or pass a resume. Our purpose is to help users identify the areas which need improvement. So that's why we break them down to a more granular level. And then step one is that we start to try to classify or predict what is each of this sentence. Like this seems like, well, this is kind of as software engineer, so it has some meaning. And that you can see that this stuff is just personal information. So we correctly detect that and we label it, well, this is just info others. There's nothing you can improve there. And so on. So we have like 5 categories we predict. Is it a job? Is it a work experience? Or is it education? Or is it project/skills? Or others? Sort of 4 categories. Once we have done that, we do the exact same exercise for the job posting. Then what we do is as a second step or as the final step, we take each sentence from the resume and let's pick an example. Let's say this education one where the person lists 6-month full-time computer science development program. And then we pull out the relevant sentences from the job description, not the entire job description, only education one. And then what we do is we try to compare and generate a score with each of those and get the max score out of it. So we are looking for something which matches the best. So let's say if this person would have had a bachelor's degree, it would end up matching with this, which is similar, bachelor's degree in computer science. That's how we kind of generate this score.
Are all of these things, sorry to interrupt, I thought you were at a pausing point. Are all of these things that you're telling us written down on the site somewhere? Because one thing that I would keep in mind is that there's a fair chance that someone is going to look at this without talking to you.
Yeah.
And so it might be good to add a place where there's kind of some summaries or some further explanations of what all of this means. Because it sounds like it's really cool and really, really neat. But one of the things that I would recommend doing, even just for the website in general, is sit someone that you know that's smart but hasn't seen this project before down in front of it and ask them to use your website and tell you what they're seeing and what they think it means. And I promise you it'll be a very enlightening experience.
Right. Yeah. We could totally have like a FAQ kind of section. We haven't spent time on it, but yeah, totally could be done where we write down what's exactly happening behind the scenes. Sean, does that answer your question? Just to add one more line, we also do the reverse. Like we did a resume to job posting comparison. We do the reverse also. We take each sentence from the job description and try to compare the best sentence we can find in the same category in the resume. And why we need that is we then come up with this list which we call as missing. So these are the stuff which is completely missing. And it's fine, maybe the user doesn't have that much experience, but at least he can take an action on it, or he can realize that maybe he can do something about it.
If we could have somebody from the group, whether it's Navjot or somebody else, do a quick rundown of the technologies used and how you guys divided up responsibilities for the project.
Cool. I think there's a lot of stuff which we can show what's happening behind the scenes. I think probably Alex should start that.
Yeah, I can.
I stop my share.
Share my screen really quick. Yeah.
You don't have to show anything behind the scenes. You can just talk about what technologies you used, and then just how you guys decided to divvy up everything.
Okay. So All the front end stuff is, I think, mostly Nat worked on. He's got a lot of experience in that space, and then everyone else is kind of more on the Python side of things. So the front end, we use JavaScript and a few other tools to kind of get that wired up, but our back end is all running on Python, and that's what's doing all the machine learning algorithms, and then we kind of just have a connection between the two, between the server and the back end there. And the Python kind of has all that output, and we just send that forward to the front end side. Something that NavDot really wasn't able to show or didn't go as deep into is that we have another endpoint that's, if you take the URL and you go to training, it kind of breaks out all of the, I'll just share. So it kind of breaks out all the different models that we used on both the resume side and the job side. You'll see at the top we have broken this out into different tabs. And so for the machine learning algorithms, there's kind of a couple features that we used here. We used several different models here just to compare and see which one we're getting the best scores on. With each of those models, we have the ability to select a feature that we're using. So we have a bag of words, which is kind of just a term frequency for each document that we have. TF-IDF, which is kind of a variation off of that. And then word embeddings, which is basically what you guys saw in that 2D graph there. And then we're able to train it and then test it on 2 different data sets. And that works also with jobs.
So quick question while you have, sorry for interrupting, quick question while you have this screen up though. So which Python libraries did you depend on for all these various models and features?
Yeah, so the machine learning models, not getting to the deep learning yet, those are all using sklearn. They have a bunch of standard models like logistic regression, SVM. You'll see up to naive Bayes here. And then after that, there's a couple deep learning, and then there's fast text. Fast text is actually what we're using right now to analyze the resume and compare it. That's a library from Facebook research that they're doing. It's not our best model, it's just the one we have hooked up and running at the moment. And then these 3 here, which are kind of our deep learning neural networks, we're using Keras, which is kind of an abstraction for TensorFlow as a backend for that. Down here for the embeddings for like bag of words, TF-IDF, we're using a package called Spacey. It's kind of like the production side of, there's a couple other packages called Jensen and NLTK. Spacey kind of takes that and is more of a production friendly package. And then word embeddings, we're using, I believe, Jensen for that because it has some of the more state-of-the-art word embedding algorithms in it. That we use to kind of split the sentences into tokens or into words, and we remove some of the more frequent ones, and then we use that data to kind of get context in the word embeddings, kind of how Navjot explained it. Anyone have questions?
So one more question.
Mm-hmm.
So you have Python code, you have JavaScript code. The Python is doing the machine learning, and what exposes those results to the JavaScript to the front end? Are you using Django or Flask, or how are you doing that?
I'm gonna let Nav take this one if you can.
All right.
Okay. So that's a good question. We had the option of using, as Aaron said, Django or Flask. That kind of eases the communication part because everything becomes in Python. But we wanted, and at least I wanted to go with Node because it's just the more standard or popular framework. So to answer your question, Aaron, we use something called ZeroRPC. That's a socket library. So what we do is we basically we take the JavaScript file and the Python file, and we create a common socket, and we try and transfer the information around. So that's the like next layer which we had to do, which was pretty problematic.
So it's all actually Node.js, but then inside the JavaScript, there's a way for it to communicate with the Python.
Exactly, yes. So JavaScript talks to Python, and that's kind of one standard way to do it via zero RPC, and it just creates another server, like a socket server, and all the data is kind of going back and through that server.
Okay, if that's it for the questions for the group as a whole, I think we should go ahead and get started on the round robin portion.
All right, then let's get started. So first off, I just want to open by saying, congratulations. It's a cool looking project, and it definitely, it's on the cusp of usefulness, I would say, which is pretty good.
Yeah, I would agree with that.
It's so. Let's start with something a little bit more fun, and then we'll dig in deeper. But overall, what do you feel is the main thing you've learned from working on this project for the past number of weeks?
For me, it's really the NLP portion of it. I wouldn't say that, we had a couple, lectures on it and talked about it a bit, but my last personal project was on computer vision, so I got really deep into that, right? And so before that, I just kind of scratched the surface of the NLP side, and through this whole project, kind of learning how to create word embeddings or other types of features that machine learning models can use to infer, or predict and classify sentences off of is probably the biggest thing that I've learned so far.
Very cool. You actually predicted one of the directions I was going. It's not, clearly NLP was one of the central parts of your project, so it's worth chatting more about. So I guess first off, in terms of, one of the more infamous parts of NLP is how much pre-processing is required. And I'm just wondering, were there any particular challenges that you faced in this project in terms of cleaning the input data? And if so, how did you try to address those challenges?
Yeah, so we did a lot of the basic cleaning, removing high-frequency stop words, punctuation, stuff like that. One specific challenge, though, is Node.js, right, is got punctuation in it. If you remove the punctuation, it becomes Node and JS, which you want to keep together. And so things like that, we kind of had to go and tell it specifically that certain phrases like that we need to keep in there.
So it's just like hard-coded special rules?
Yeah, for the majority, because there's not too many skill sets that we're mainly focused on web development in this 4 weeks here. So for us, hard coding was kind of the answer instead of figuring out some way to figure that, get that every time, because they're not always just a period, it can be something else. And another challenge in general, I would say, with data is the amount of it. We're kind of limited on, 3,000 sentences on job resumes and even less on the job postings themselves, which makes it difficult to kind of filter out some of the noise.
Is there anything, aside from just getting more data, was there any approach you tried to take to address that?
So that's why we were using different types of features to see if we could extract information differently, because word embeddings is highly constrained by data, because the more usage of different words that you get, the more it can learn to kind of cluster certain words together, right? And so if we don't have enough data, it won't work as well as maybe say bag of words or TF-IDF, which is the extension of that. So if you kind of can just use the frequency of words and then its inverse document frequency and get an overall score, maybe that can help us out a little bit better. That happened to be, TF-IDF happened to be the best scoring machine learning model, and then on the deep learning side, we actually used the word embeddings to get our best model. So.
Gotcha. Yeah, we should dig a little more into TF-IDF, but before we go there, with all these different models, did you try any sort of ensemble at any point?
No, we weren't able to make it to an ensemble. All the ones that we tried, we we're doing them just by themselves, trying with different features, and then try to tweak if they're deep learning, we try to tweak their layers and, different type of parameters and stuff like that. But we never did get into unsolvable one.
Fair enough. So let's see here. A few more specific NLP perhaps, and then we'll branch out because NLP is a good topic though. I well. So yeah, let's say you had to explain TF-IDF to what's a good target audience? Well, let's just say a non-technical coworker. A nice, intelligent but non-technical coworker. How do you explain TF-IDF to them?
Yeah, so I kind of start with there's two parts of it: the term frequency and then inverse document frequency. So the term frequency is we have a bunch of documents kind of queued up when we're going to learn, and or if we're training the embeddings TF-IDF model, and it's going to look at how many times a word occurs in a document. And the basis of that is if a term in a document is more frequent, it's probably a more important thing to pay attention to. So that can be an indicator of some information we want to retain. And then on the other side, you have the inverse document frequency, which is trying to kind of negate certain words being like a term occurring in every document, although it may have high frequency. Like if it occurs in every document, it's really not going to be that useful.
Can you think of an example?
Well, so if you kept you usually remove stop words, right? If the is in a document, it's not going to provide any extra information, even though it has a high frequency in each one. That's how we mitigate that. Is now that we see that it's in every document, we can kind of degrade its score because it's not going to tell us anything additional.
That's exactly it. So essentially, the intuition that you're trying to capture is surprising or unusual words almost.
Yeah.
Which makes sense, and it's simple but effective. I mean, I'd have to look up the details, but it's foundational to search. Even it's been around.
Mm-hmm.
But all right, is there anything else you want to chat about NLP wise? Any like cool NLP thing that you sort of got jazzed about the past few weeks?
I think something we didn't get to show on the demo there, but it's pretty cool, is actually visualizing the embeddings. You saw like a 2D one, and we kind of briefly went over it, but there's some other functionality that we were looking at where we can do 2D and we can kind of color things, and then we go to 3-dimensional as well, and then you can kind of rotate around and see what clusters have been made, right, and like the web technologies. And I think that's kind of cool because it's a unsupervised model. It's just looking at the context of sentences and kind of self-realizing that, which is, I think, the most interesting part of it. NLP.
Very cool. All right. So that said, you've been with us here at Lambda School for a number of months, and we indeed study all sorts of things. So let's dig into a little bit of that too.
All right.
Some of these are questions that you may have even received already in earlier interview practice, but that's okay. Sometimes practice is about making sure you remember questions too. So let's just start by talking about the general difference between supervised learning and unsupervised learning in one situation where one is appropriate versus the other.
Sure. So supervised learning is a way of training machine learning algorithms by providing samples or features that is the information you want to learn from, and then on the other side you have labeled data, which you're trying to tell it that. An example would be binary, like a yes or no. If someone, if you have data where whatever the result is either it didn't happen or it did happen, that would be supervised learning. Unsupervised learning is essentially taking away the labels part. You're giving it information and you're kind of letting it try to figure it out.
And just like the word clustering you talked about.
Yeah, exactly. And another part that we were looking into was for sentence classification was an algorithm called k-means, which is kind of it's a clustering algorithm in itself, where it's trying to find centroids, and we give it how many centroids it's looking for. And so in our case, we had 4 labels. We had education, skills, others, and one other class.
Can you define a centroid?
What was that?
Define a centroid.
Centroid would be kind of the center point of a cloud of points, essentially.
Sure, and it's okay if you don't I don't know the math formula completely off the top of my head, but if you can characterize a little bit what it means to be at the center of a cloud of points.
Yeah, so it's kind of the average of the space that they are in, right? If you're an X and Y, it would be the average in X and Y of this cloud that you're trying to kind of classify. Or
I mean, is it calculated by averaging the points, or is it calculated by trying to maybe minimize deviations from the center?
Yeah, so you would take, I think it depends on which.
It does depend on which approach you're taking, yes. Oh, your audio just cut out.
Oh, back.
All right.
Yeah, so the approach, if you know the cluster, then you can kind of know their X and Y points, and you know everyone that's labeled in it. If it's not, and you're trying to use a k-means or something like that, you've kind of randomly placed centroids, and now you're finding the difference in the kind of error between them. And so if you add a new point in, it's going to shift your centroid.
Makes sense. We only have 2 minutes, so let's go back to supervised learning real quick, since that is kind of important. What's a model that you would use, or let's just start with a model that you would use for predicting that 0-1 situation.
You could use in our model, or even our demo, we're using logistic regression. We're using multinomial logistic regression. So it's predicting up to 4 classes in our case.
Gotcha.
Yeah, it would be either 0-1.
All right. And roughly, how does that model work? I know it's going to be hard to fit that in a minute and a half, but what's the math in a nutshell of that model?
Yeah, so you're trying to, it uses the logistic function to minimize your error between points, right? Kind of like or logistic regression would do this, right? Or, linear regression. And then we're just using a logistic function instead. And then it produces a curve where you have a threshold, essentially, to where it wants to classify, in a binary sense. If you're above, let's say, 60%, it's going to say that it is yes or 1, or below it's going to be 0.
Yep, sounds good. Well, you're probably going to be booted out in just a moment, but thank you. And
all right, thanks.
Hey, Alex, thank you for taking the time to speak with us. So I've just got a couple of questions about you and who you are. So to start out, could you tell us a little bit about yourself, what you did before Lambda, and how you found yourself a Lambda student?
Yeah, so my background before Lambda is I have a bachelor's degree in mechanical engineering. I spent a year developing amusement park rides. So roller coasters, parade floats, and that stuff for Disney and Universal. I actually used to live in Orlando, Florida.
That's amazing.
Yeah, so that's what I did before. And I actually moved out. I moved where I was. Mechanical engineering wasn't the only thing I wanted to do. I'm actually really kind of a multidisciplinary person. I really enjoy other aspects of mainly engineering and technology. So I moved to Denver, and there's an event called Denver Startup Week, and people talk. And actually, one of the previous instructors, Thompson, who used to run, he started out the machine learning course. I actually went to a talk of his, and that's how I found about Lambda. And I thought it'd be really cool to stay on the cutting edge of AI and data science and stuff like that, and how I could use that to mainly use it for physical. Interacting with the physical world, and how we can kind of use that data to make decisions. And so a lot of other things I'm interested in. I do a lot of electronics, prototyping, that type of stuff. And so it kind of fits into the IoT world, where you have sensors gathering data, and you can kind of make predictive decisions and make make things on that.
That's really cool. And I can promise you, every interview that you ever go into and you tell them, it's well, I used to design roller coasters, but I think what you're doing is cooler.
Yeah.
They're going to be really happy to hear that. That's very cool. Awesome. So what do you think the most important thing you learned during your time at Lambda is?
I'd have to say that learning to think in terms of how you can use data to use it with the tools that we learned in Lambda to make a significant decision or something significant at the end of it. Before, like in my mechanical engineering background, data was things you got in Excel spreadsheets, right? And then you kind of a few cells or a few formulas and stuff, and you used that data in a way that was like concrete. You had a formula and it spit out an answer, right? The biggest thing I've learned is you have to think of data differently and how it can help in an algorithm that doesn't know what you're trying to learn kind of make its own decision and how that information helps the model learn. So.
All right, very cool. So how about working on a team? I'm guessing this is probably not your first time working on a team.
No, so I'd say there's several times I've been working on a team. In college, I was part of a mechanical engineering club, and so I was actually one of the part of the leadership of that. And so we organized meetings and stuff, and kind of sub projects that we did, like building go-karts and stuff like that. And so that was kind of team there. And then in my mechanical engineering professional career, we were kind of placed on small teams for whatever project that we were working on. And it was cross-disciplinary as well. I was a mechanical engineer. We were working with structural engineers a lot, which are similar, but they have kind of a different skill set that they've learned through college. And then coming to Lambda, also everyone has kind of different backgrounds, and we're all, put into teams as well. So I've had a lot of experience, I think, working with different people in different backgrounds.
So do you think working with a software team is pretty similar to working with a team doing physical elements, or was it different?
It's completely different, mainly because of the tool set that you're using. Because like in code, you kind of get away with editing the same file at the same time with Git, and you kind of have conflicts and merging and stuff. But in the physical world, it's usually pretty limited to like, I have this file, nobody else can work on it type thing, because you're making changes that can have a ripple down the whole thing, and then the whole thing could break or something, which I guess can happen in software. But I don't know. There's similarities and differences to both of them, I'd say. And especially as things are becoming more cloud-based and collaborative, I think there's kind of an emerging point of tools.
For sure. So what was the most difficult thing you had to overcome during the course of your capstone project?
I would say kind of understanding the different models and how they relate to NLP, or natural language processing, because you can construct them in different ways as to extract features for whatever data you're using differently. And so Navjot and I actually went back and forth a little bit about how our best model is a convolutional neural network. And I had made an original kind of architecture for it. It didn't work out very well. And then we both read up on it, and we were kind of like, going back and forth on what to add in there. And we eventually got it to our best predicting model. So yeah, that was kind of difficult.
All right. So is there anything else that we haven't talked about that you want to say?
Not that I can think of. I kind of going back to our demo, I think there's a few cool things that we didn't really get to show in there. There's a few other tabs that, we did all of our modeling, or our different models. We kind of, you saw where you could select them. There's a few other tabs where you can kind of select a summary and you get this graph, and it shows all the models side by side and all the stuff. That I think would have been a cool part to show, but.
Well, that's the thing with demos, is there's usually always more to show, and it's just picking what to do in what order and how to make use of the time.
Mm-hmm.
All right, well, that's all I've got for you. The last thing that we just say to everyone is, please stay in touch, not just after you get your first job, but let us know, what you're up to 2 years from now, 5 years from now. We have a lot of work and partnerships with hiring partners, and I'm really looking forward to the day that former students start pinging me and say, hey, I want to be a hiring partner. Like, hey, I've got positions for 3 engineers who are going to report to me, and I want to land a student.
Yeah.
So just stay in touch. Let us know what
For sure, yeah. I'm excited to see, I mean, Lambda's pretty new in itself, so I'm excited to see where it goes. The model of it, I think, is a great idea, and having these hiring partners come in, which I think is just kind of starting.
Mm-hmm. Yeah, we're just, working on with all of it, getting it implemented, smoothing it out, figuring out the best way to work. And one of the great things that we are able to do is we can, experiment a bit and, try different things and see how they work out, and then adjust and improve so that, we can do what's best for getting people jobs.
Yep. And I would say staying on top of current technology too. If you go through some of the university systems, they can kind of get dated in terms of the tools they use, right? Because professors like what they know and don't always keep up with the times. So I think
it's not just that, it's dealt into, universities have to be careful with what they do and how they change things because it can impact their accreditation.
That's true, yeah.
All right, well, that's great. I'll go ahead and cut this off here.
Cool. So could you fill me in a bit on, because I don't think it was that clear from the demo, but exactly what were kind of your contributions to this project? What was kind of your main responsibilities, and maybe your own thoughts on your own thoughts on it, your own take on it, I guess.
Yeah, so the majority of what I contributed to the project was on the actual implementing the models and kind of the behind the scenes of the actual structure of the models. So we had a few like subclasses so that everything didn't change around when we added a new model. And so we had like a main sentence classifier class, and then underneath that was kind of the sklearn or like eras, which were the deep learning, machine learning models. And then under each of those, we developed, each of the models themselves. And so that was kind of my main portion, was developing that structure and which models we were using. And then once the models were implemented, we kind of had to change around hyperparameters and see what helped and didn't help. And then, so overall, yeah, I think of the project did a pretty decent job. I think, more time would have a little better results, but I think that's with every project, right?
Yeah, always the case.
But it can be informative at times. Sometimes the scores are kind of like not what you expect from a human perspective, right? But the machine, depending on how it sees things and how it's been trained, and that kind of brings me into the amount of data we had, right? Mm-hmm. So
sure.
I think in general it could have been helped with having more data. We had like I don't know in terms of resumes, but I know in terms of sentences, we had like 6,000 sentences is all for the training data. And so, usually you'd want, tens of
that. Yeah, it doesn't sound like a lot.
Yeah. And then even less for job postings. We only had like 600. However, on the job posting side, that was a priority time management deal there, where we had a scraper that would just scrape Indeed jobs, and we could just parse through those and have time to implement it. Because on the flip side of more data is because we're using supervised learning, we have to label all that data ourselves.
Wait, I heard unsupervised. Was it supervised or unsupervised?
Both.
Okay, sure.
So for the words, it's unsupervised. It's trying to find clustering of different types of words and how they fit together. And then for the actual sentences, we use those embeddings that were unsupervised, learned from the unsupervised models. We use those as features or data to feed another algorithm that is supervised. So those ones, we labeled each sentence as like work experience or other. When we labeled it other, we're kind of saying we don't know what it is, but like skills, work experience, projects, or education. And so that was the supervised part. And so for each sentence, we had to label like, is this education, or is this other, or is this project or skill? And so that was kind of difficult.
Okay. clear something up for me. So what's the difference between the word embeddings and the sentence embeddings? Because I'm hearing that thrown around a lot. Does one depend on the other, or are they totally independent? Like, what are they for? What do they mean? What does that mean?
So from my understanding, sentence embeddings, at least the way that I've used them or have seen them used, is dependent on word embedding. So you learn the word embeddings, and then the sentence is made up of words.
Mm-hmm.
And so you can use those vectors or the information from the words to kind of average or combine them up into a sentence. How do I describe this one sentence?
Mm-hmm.
So you can get, let's say they're 100-dimensional word arrays, you can get one 100-dimensional vector for the sentence by kind of averaging everything up.
Sure, okay.
Go even further and then learn into like a document space. You can take all the sentences or all the words and get that into one representation of a document even. And then you can use that information to figure out similarity and stuff from how they kind of fit in dimensional space. That makes sense, right?
Yeah, kind of. So you're saying each individual word, you assign some value to it. You take all the words in a sentence that conglomerates into one value for a particular sentence, and then conglomerate all the sentences for a document.
Yeah, and if all things being equal, if a sentence is really heavy in certain words, certain technologies and words,
mm-hmm.
those should theoretically be close in their dimensional space, right?
Mm-hmm.
So it's 2 dimensions, they should be close to each other on that graph that you saw. And so if you have a lot of those words, when you add that all up, it should have its own kind of space. And like, let's say the document's highly technical, it should be in that kind of technical space, right? Because it's using all technical words.
Yeah.
So you can use that. If you're thinking about 3D space, you can say that like these documents cluster over here, and like maybe, I don't know, non-technical ones are somewhere else in space, and you can look at their distance space and then see how similar they are, essentially.
That makes sense.
Yeah. And so, there's different techniques you can use to kind of play around with the dimensions and stuff like that. When you have to select how big you want your vector for each word is when you start. So it's like 100, you could choose 2, and it's kind of a hyperparameter. It doesn't necessarily give you more information to have a bigger vector. It may or may not. And then that, if you have too many, it may not be something that the machine learning algorithm can decipher later on in space to actually separate out different words, like technical from non-technical.
Cool. So you worked a lot on the models. So, and from my understanding, it seemed that you guys used one model for the demo, but then apparently that wasn't the best performing model.
Yeah, so we were using that because it was stable and we'd been using it for a while, and there's a little bit of legwork to kind of connect it up to use as the primary model, because we had it trained and we had a way of testing it. We didn't create a function. There's a separate function that we use to actually go through the document itself, and it's kind of has to do with connectivity between the Python side and the JavaScript side. So we weren't quite able to get that, mainly because we were limited on resources there, because NavJava is kind of the heavy hitter on the front end side. Being on the machine learning course, we didn't learn the front end side of it.
Sure.
And so it was kind of a bottleneck there. So we weren't able to switch it over and make sure it was stable and everything.
So I guess from my understanding, it seemed like the neural network was the quote unquote better performer, but I guess what you're saying is not as stable.
Yeah, because we were messing around with structures and what data is being input. And so you remember when you saw those features, there are like 3 or 4 different feature choices.
Mm-hmm.
Those come in different shapes. And so if one comes in a certain shape, we've got to reshape it and to make sure that the data is what the model's expecting.
Mm-hmm.
And so we were playing around with like the architecture and layers and stuff. And so if the reason we were using, especially for the demo, fast text, is if we're using an experimental model that we said was the best, during the demo we tried to like use some other data, right, and accounted for that yet, it would just crash it, and we didn't want it to happen, right? So it would just say like, hey, I'm not expecting that data shape, and but fast.
So the neural network just wasn't as well tested.
Yeah.
Okay.
The fast text we'd use from the beginning just because it was out of the box, like a good model, right?
So what even tells you then that the neural network is quote unquote better?
Yeah, so there's several different scoring techniques, and we didn't get to go through in the demo, but there's the endpoint that we can hit, that training endpoint, to see all the different models. And when we train one, it comes out with 3 different scores at the end. Score of like how many true positives it got, and then like how many false positives, and then like a combination of those 2 scores. Precision, recall, and F1 score are the 3 scores we get out.
Okay.
And then there's variations on that. So you can just train on data and then test it on that, but you'll get a really high score because it's seen all that data, right? And so we had a separate test, a test database that we would draw from to test it on unseen data, and then that would be kind of the first defense of comparing the models to each other, because that truly is unseen data. So if one performed really good on training with on test was really bad, then we would know there's a difference there. And then additionally, during test, we would do something called cross-validation, where we wouldn't test it on all of the data anyways. We would test it on 80% of it and train it on 80%, test it on 20%. And so that kind of gives you technically unseen data while it's training as well. So we can kind of see all these metrics, and ones that, like the CNN, consistently outperform the other ones in all the metrics, basically. So like on training, on the data it saw, it was like 99% accurate. It essentially didn't miss any. It didn't perform that well on the test. I think it was at 80% or something like that, 83%. But fast text, for example, was 74%, I think. It got 74% of the results right. So there's a bunch of different metrics that we looked at.
That sounds really cool, though, that it sounded like you guys constructed this pipeline, and each one would test different, like this pipeline would test all the different models so that you could kind of compare the metrics side by side.
Yeah. The models are highly dependent on the features that you're giving them and like what information it can extract. And that's different for like regular machine learning algorithms, like the more statistical based ones, or like the deep learning ones. The statistical ones couldn't extract as much information out of the embeddings. So they were kind of constrained to the word, it's called bag of words, or TF-IDF, like kind of like term frequency. So the machine learning performed better on those, but the deep learning ones had a little bit more complexity, and so they could extract more of the information out of these 100-dimensional vectors, basically. And so that we did that purposely for that, so that we could see them side by side and make sure.
Is that sort of pipeline just really common in when you're doing data science type work? Do you happen to know that? That sounds really interesting to me.
I would say that you got to cover your bases. Like, if you're doing one model or something, these other ones don't perform way better. So,
anyways, nice talking to you, Alex.
Hey, how's it going?
Hey, good.
We're just finishing out. It's funny, you're like, they're gonna cut me off.
Well, they didn't get it cut off.
Yeah. Cool. So I've started every interview or whatever we're calling these off with the caveat that I'm a web developer, and I've been in web development like my entire career.
Uh-huh.
So I've done a tiny bit with Python when I worked at a company that had a Python Django application that I was converting to JavaScript and Angular. Did a little bit there, but that's like the most exposure I've had to back end, and even less exposure to machine learning and data.
Okay.
With that being said, did you work on the UI at all? What did you have your hands in as far as the client?
Yeah, so for the UI side, really not very much. basically, because I'm kind of the opposite of you. All my experiences in Python machine learning, and then before that, I was a mechanical engineer, so that doesn't port over. So, yeah. So UI side, I helped a little bit with the connection layer, not necessarily setting it up, but kind of coordinating with NavJot what arguments we're passing through. So, like if JavaScript's calling something, it's passing text in as an argument to a lot of our machine learning models to tell it like if it's on resumes or jobs that it's training, and then further like what information or features we're passing it to learn on, basically. So yeah, a little bit of coordination there, but really not in terms of coding. I didn't.
No problem. Yeah, that connecting piece is always interesting. It's because you've got two separate programs that are running, and you need to share data back and forth. And
yeah.
Your JavaScript, your client app needs to send the right strings, the right arguments to get the right back. So yeah.
And there's to that point, there's a few times we made a couple typos, and so like you think it's doing something right, and it just keeps crashing every time. It takes you 30 minutes to figure out you forgot to put an I somewhere because it's just strings, right? So.
Yeah, I'm sure I can imagine that's hard to debug.
Yeah.
Cool. What for any part that you worked on, what were some challenges you faced? Like, what was the hardest thing you did, and how did you overcome that in this project?
So I think one of the hardest and more of the frustrating parts of it was getting the models to actually predict well on like the information we're giving it. I think a lot of people think like machine learning models, you can just throw anything in and you'll get, a good result, but it really depends on kind of how especially in deep learning, how the model is layered and like actually constructed. Mm-hmm. So a lot of the like statistically based machine learning algorithms work pretty well out of the box because there's really not too much to them. But specifically the convolutional neural net, which ended up being our best model, was highly dependent on what we were doing in what order. And so that just took a lot of research, like reading online and like what other people had been doing that get good results. In the beginning, I just kind of threw random ordering in there that I thought might work, and it wasn't good at all. So, I mean, it did decent, but not as good as it can. And then, so that kind of leads even into like optimization of it. Like, how do you know what to make or what to change to make it even better than it was before, and what information to give it? So, I think just getting the score to be good was pretty frustrating.
It's funny, for us that don't know a lot about machine learning, like just by the title, you're like, oh, these machines can just do it. Like it'll learn it. No, you have to teach it how to learn it.
Yeah, you have to build it to learn it and give it the right information.
Yeah. No, I thought how it was laid out was really great on the UI, the graphs and everything. I think I've told everybody that the biggest feedback I had as far as the client application was pretty much what Brian asked during the introduction is, okay, we see this data laid out on the screen really nicely. What does it mean? Like how, if I haven't been writing those algorithms and passing that data up to the JavaScript app, I'm not going to know what is minus 40 if I'm at minus 30 and plus 20.
Actually, that's a pretty good point. Actually, and something I think you can kind of get buried in the the technical side of it without realizing this is for like an end user that doesn't know any of this. And so, bringing that up, I think is something we kind of overlooked in terms of the UI, that we could have put descriptions in and like, this is what this is, and you like hover over it maybe and give you more information or something.
Yeah.
In general,
that was my biggest feedback from my perspective as a UI guy. So
yeah.
Do you have any questions for me now that you're kind of at this point, finishing up with the program, getting ready to jump into interviewing? Do you have any questions for me?
Not really. I kind of actually have a job that I landed last week, so
sweet, you're there.
It's it's partially machine learning, partially electronics and like prototyping things. So I'm kind of using my mechanical engineering together with data science. Yeah. So
That's kind of a cool combination.
yeah,
Yeah.
it's kind of where I want to be in terms of using machine learning to make physical predictions, if that makes sense. Like using sensor data and stuff to make predictions about the environment around you, right? Instead of, I don't know, something that always comes to mind is like Facebook information. There's a lot of information on Facebook, but you're really like, you're just kind of figuring out behaviors of people, I guess. But what I want to do is kind of stay more on the physical, maybe even robotics side of things. That's where the electronics comes in.
Yeah. Yeah, that's cool. With mechanical engineering, do you do, how different is mechanical engineering from electrical engineering?
Kind of, you kind of learn, there's a few introductory classes you get into electrical, but it's pretty different. Like the things you're dealing with are, for one, you can't see it, feel it, like it's not physical, right? Like mechanical engineering is all pretty much physical things that you create. Electrical, a lot of the times you're testing instead of seeing anything you create. But I'm kind of just learning as I go right now. I'm teaching myself a lot of the electronics on the fly as I have to do projects and stuff like that. So.
Yeah, I was gonna say, because a lot of the stuff you'd be wanting to use machine learning for, you're gonna have to have some controller. You're gonna have to do some of the electronic work.
Yeah. So that's kind of my role at this job is we have clients come in, they have an idea that they want to do, whether that's like collecting sensor data or some other guy who's doing measuring certain aspects of like when you're skiing, there's a device you put on ski and you get like angles and stuff out of. And so yeah, it's all this. You have to kind of collect the information and send it somewhere.
Yeah.
And it's got to be, once it gets somewhere, you've got to be able to process it somehow, and then in some circumstances get it back to the device.
Yeah.
It's there that have to happen.
Or to some UI to display.
Yeah, exactly.
That you came up with, yeah. Or just export it as a CSV or something.
Yeah. Well, one of the in-house research things we kind of did here was we put temperature and humidity sensors in all of our rooms. We have a 10,000 square foot office area here. Mm-hmm. And then all the thermostats, we put another device on that could tell when the air was on. We have like 4 different air handlers. And so we sent all this up to Amazon Web Services. We had a database there and then some other Python code around it that would send information in like JSON format to a front end. I didn't do it. I kind of did the front end, but a lot of the heavy lifting was kind of done with Amazon because they'd make it pretty easy to kind of send information back and forth. But yeah, we display on a graph like what the temperature for each zone is and what air conditioners are on and stuff. And so you could potentially like use machine learning to kind of regulate all these different rooms, make sure that the building's the same.
It's kind of like
Nest
2.0.
Yeah, more higher resolution Nest, because in the Nest you still only get your 1 point.
Yeah, just that one reading, yeah. But it does machine learning where it starts to understand over time what you've set the temperature to.
Yeah, so you could give it like, you could set a temperature for all these rooms, and then it would learn over time that if it turned on, it's getting further away from the right temperature, so it actually has to go the opposite direction, right? But then when you have like 4 rooms, it's got to decide what's the optimal, point between the 4 rooms on that zone, what minimizes the error, I guess.
That's so cool.
Yeah.
We didn't call it a capstone project, but my capstone project for the boot camp I went to was we had a Arduino chip and it connected to a webcam and a motion sensor. And we put that in at the entrance to the school, and the motion sensor would be triggered. It would take a picture, and then we built a UI for the.
You display it or do whatever you want.
Security camera, yeah.
Yeah.
And then we had some environmental, we had like a humidity sensor and a couple of things we plugged into it.
Yeah.
Blade and grass, but we didn't do anything like machine learning with it, but it was
Yeah,
really
I mean, that's kind of where everything is heading, basically. All these sensors are becoming so cheap to the point, why wouldn't you put it somewhere, you know? Why not have it there, especially if you're building a building, you know? You can just embed it all the way through. So, I don't know, it'll be pretty interesting. A big downside of that, or potential security, or is security with that, though, like, you have to maintain all these devices. You can't forget about them, and then someone can get in your database or, you know, whatever.
yeah.
We'll see how that plays out. But.
Yeah. Cool. Well, sorry, we can dig more into your Python algorithms and grill you.
No
on
problem.
things.
I enjoyed the conversation. It's good.
Yeah.